Algebra 3, Chapter 6, Section 4, Graphs of Sine and Cosine Functions. Sine and cosine curves. So now that we have related everything with our trig functions to the graph, to the xy axis, we can actually graph them on the xy axis. The x-axis, the x value, will represent the value of an angle, and the y value of that for that x will be the trig value. So if we're graphing a sine curve, each x on the curve represents an angle, and its matching y represents the value of sine for that angle. So when you do that with a sine curve, this is what it looks like. Notice some of the features. It goes through 0, 0 because the sine of 0 is 0. The sine of pi is 0, and the sine of 2 pi is 0. The sine of pi over 2 is 1. The sine of 3 pi over 2 is negative 1. So you can see how those values match up there. Notice it stays between negative 1 and 1. And again, it repeats a pattern. It's a periodic function. The cosine is very similar. In fact, it looks like you took the sine curve and you shifted it about pi over 2 to the left. And so we have when the angle is 0, the cosine is 1. And when the angle is, again, 2 pi, the cosine is 1. It's going to be negative 1 at pi, and it crosses the x-axis at pi over 2 and 3 pi over 2. Like the sine curve, it stays between negative 1 and 1, and it is periodic. It is repeating that wave pattern. Okay, so looking at the sine and cosine, a few facts. The range for both is negative 1 to 1, while the domain is all real numbers. In other words, you could put any real number you want in for theta, and you will get a cosine or a sine for that. Each function has a period of 2 pi, which means that one complete cycle of, from middle to up to middle down back up again takes up a space of 2 pi. To sketch the graph, now we're going to be doing some graph sketching. And what you're going to do, and I know you're going to want to go to your calculators, and your calculators can back you up, but you need to do a lot of this by hand and use your calculators as confirmation. What you want to do is you want to plot the high points, where it hits 1 and negative 1, and the low points, high points and low points, and then you want to plot where it cuts across the x-axis. You want to do that for one period. Once you've got one period, you can always repeat it, and then you connect a smooth curve. The standard equations look like this. It's really nothing different from what we've seen, except we usually put the thing that you add on at the end. Here it's going at the beginning. Remember, just like any other equation we've talked about, that d that's added to everything is going to move the graph vertically, up or down. The a is going to affect the height of the graph, in this case, what's called the amplitude of the graph. Numbers added or subtracted from the x, like c, shifted horizontally. Now, it's a little bit more complicated here because that bx plus c in parentheses, the b is going to affect it too, and we'll talk about that when we get there. And we've already said that the numbers added, the d is going to shift it vertically. The numbers multiplied to it cause stretches and shrinks. With the b in front of the x, that's going to actually affect the period of the function, and the a in front of the sine or cosine is going to affect the height of the function. The amplitude of a curve is the height measured from center, or you could consider it half the distance between the maximum and minimum values. For our equation, we find the amplitude by taking the absolute value of a being the number in front of the sine or cosine. Period is typically 2 pi for sine and cosine, but when a number is in the place of b, it changes. To find the period for your new function, you do 2 pi over b, and that new period. C will shift it left and right, and b will affect the period. One period of a regular sine or cosine goes from 0 to 2 pi. B and C are going to change this. In a curve, this is called a phase shift. The amount of the shift is determined by C over B. So to actually figure out that horizontal translation, it's not just C, it's C divided by B, and that's going to give you the horizontal or the phase shift. We can find our new endpoints by solving these two equations. Or another way of solving it is kind of combine it into one and do 0 is less than bx minus c, which is less than 2 pi, and you can kind of do it that way. All right, so here's some examples, a lot of them. Find the amplitude and the period. That's all you got to do, amplitude and period. There are no translations in this. Pause the recording, give it a try, and resume to see how you did. For the first one, our period is 2 pi over 5. Remember, what you do is take the number in front of x, put 2 pi over it. The amplitude is 2. For this one, it's going to be 2 pi over 3, which simplifies to 6, and the amplitude is 1/2. For our next one, it's just 2 pi. There's nothing in front of x, so it's just a normal period, and the amplitude is 4. Remember, the amplitude will always be a positive number. The negative, as with other functions, will actually cause a reflection. So the amplitude is positive. For the 5/3 cosine 4x over 5, the period is 2 pi over 4/5, which simplifies to 5 pi over 2, and the amplitude is 5/3. And finally, the period for this function is 2 pi over 2 pi, which is 1, and the amplitude is 1/4. The relationship between the graphs of f and g, consider the amplitude, period, shifts. In other words, tell me how g is different from f. Pause the recording, give this a try, and resume to check your answer. Okay, in the first one, what has happened is there's been a horizontal shift or a phase shift to the right. Remember, it's kind of an opposite thing with x, pi units. For our second one, we have got a period difference, and the period is twice that of f. In other words, the period for f is 2 pi, and the period for g is 2 pi over 2. So, sorry, the period for f is twice that of g, or g is half that of f. Now consider the relationships between the graphs of f and g. Consider the amplitude, the period, and the shifts. Between the red graphs and the blue graphs is what I'm talking about. How are they different? Pause the recording, give this a try, and resume to check your answer. Okay, so for the first one, the graph of g, which is the red one, the red graph has twice the amplitude of the blue graph. The period is the same. In other words, you'll notice that the same number of curves go by in the same distance. The only difference is that the red graph is a lot higher and a lot lower, so the amplitude is changed. The blue graph is an amplitude of 1, the red an amplitude of 3. And now do the same thing for the other one. Okay, the difference between the red and the blue here is that the red graph is a shift to the right of the blue graph. So it's a horizontal shift or a phase shift of, in this case, it's not marked, so you may not have known the exact amount, but it's supposed to be a phase shift of pi units to the right. The sequence of transformations from the sine of x or cosine of x to g, and then sketch the graph of g. In other words, in this case, g of x is sine of 4x minus pi. So you starting with sine, compared to the sine, what has changed? Be specific about the amplitude, the phase shift, the period, all that, and then sketch a graph. Pause the recording, give this a try, and resume to check your answer. Okay, so g of x is obtained by a horizontal shrink of 4 and a phase shift of pi over 4. Remember, the number in front of the x affects the period. In this case, the original period was 2 pi. This one is going to be 2 pi over 4. So it's going to be pi over 2 is going to be the period. It's a horizontal shrink. It's going to be, in other words, it's going to be scrunched into a smaller space. And the phase shift, now you might think, okay, well, it's been moved to the right pi. No, remember, it's kind of weird with these. You got to do pi divided by the number in front of the x. You got to do a little division there. So it's pi over 4. It's going to be moved to the right. You can figure out what one cycle is by, like I said, solving the equation. 4x minus pi equals 0, and 4x minus pi equals 2 pi. And that tells you that it's going to go, one cycle will go from pi over 4 to 3 pi over 4. And there we go. transformations again from the sine or cosine, in this case the sine, to g of x and sketch the graph. Pause the recording, give this a try, and resume to check your answer. Okay, g of x is obtained by a horizontal shrink of 4, a phase shift of pi over 4. Again, remember, you got to do that division there. Shifting at 3 units downward, and it has an amplitude of 2. Here's what the graph of it looks like. I'm giving you the graph, and you need to find the function. Now, it's going to be the form a cosine x plus d. You need to find a and d. Pause the recording, give it a try, and resume. Check your answer. Okay, the amplitude is going to be half the distance between the highest and lowest y value. Highest and lowest y value would be 3 and negative 1. The distance between them is 4. Half of that is 2, so a is going to be 2. D is the line that basically runs through the middle of that. It's the center line, which halfway in between negative 1 and 3 is positive 1. So D is 1, and our function would be 2 cosine x plus 1. Now write an equation for a function that's described. And there may be different possibilities, but this answer is going to be one of them. A sine curve with a period of pi, an amplitude of 2, a right phase shift of pi over 2, and a vertical translation up 1 unit. Okay, this is a little difficult. Keep in mind that the period is 2 pi over b. So remember, and the main function that we're using is d plus a sine bx plus c. Pause the recording, give this a try, and resume to check your answer. Okay, here's a possible solution. The b has to be 2, because 2 pi over b has to give me pi. Well, then b must be 2 to make that happen. The phase shift is pi over 2, so that means that c over b has to equal pi over 2. We already know b is 2, so c must be pi. The amplitude of 2 goes out in front, and the vertical translation plus 1. Now, you may wonder why it says this is one possible answer. You actually could do this with a cosine curve. Believe it or not, you would have to have a different phase shift. There are other possible answers. This is actually the simplest answer and the least complicated. Exercising for a few minutes, a person has a respiratory cycle for which the velocity of airflow is approximated by v equals 1.75 sine of pi t over 2, where t is time in seconds. Inhalation occurs when v is positive, and exhalation when v is negative. Find the time for one full cycle. In other words, find the period for A. For B, find the number of cycles per minute. In other words, in 1 minute, how many of these things are going to go by? And then C, sketch the graph. So pause the recording, give this a try, and resume to check your answer. Okay, the period is going to be 2 pi over 2, which is 4 seconds. So one full cycle takes 4 seconds. Now let's use a little logic. If one cycle takes 4 seconds, how many of those are going to go by in a minute? Well, 4 into 60, 15 cycles per minute. And here's the graph. When tuning a piano, a technician strikes a tuning fork for the A above middle C and sets up a wave motion that can be approximated by 0.001 sine of 880 pi t, where t is the time in seconds. Find the period. The frequency is the reciprocal of the period. What is the frequency? Pause the recording, give this a try, and resume to check your answer. Okay, the period is 2 pi over 880 pi, which is 1 over 440 seconds. Very fast vibration there. And the frequency would be 440 cycles per second. In other words, in 1 second, that string, that wave has vibrated. It's not a string, sorry, it's a tuning fork, has vibrated 440 times. A Ferris wheel is built such that the height in feet above the ground of a seat on the wheel at time t in seconds can be modeled by this equation. Find the period. What does it tell you about the ride? Find the amplitude. What does that tell you about the ride? And graph. Pause the recording, give this a try, resume to check your answer. Hey, the period is simply 2 pi over 10, which is 20 seconds. What that tells you about the graph is that it takes the wheel 20 seconds to revolve one time. The amplitude is very simply 50. The amplitude is the radius of the wheel. In other words, from top to bottom, the ride is 100 feet. And here's the graph.